Welcome back to Daily Dose of Space. When we talk about the universe, we usually focus on its past. The Big Bang, the first stars, the birth of galaxies. But today, we're going to talk about something else. The future. Not the near future, and not the kind that affects us directly, but the deep, unavoidable future of the universe itself. Because according to everything we currently understand about physics, the universe is slowly, quietly running out of time, not exploding, not collapsing tomorrow, but fading. A universe that is changing direction. For a long time, scientists believed the universe might eventually slow down, that gravity would pull everything back together, reversing the expansion. That idea is now gone. Observations show that the universe is not slowing down. It is accelerating. Distant galaxies are moving away from each other faster and faster, driven by dark energy. And the more space expands, the more dominant this effect becomes. This means something important. The universe is not heading toward a dramatic end. It is heading toward isolation. Galaxies outside our local group will eventually move so far away that their light will never reach us again. Not because they disappear, but because space itself stretches faster than light can cross it. Over time, the visible universe shrinks, not physically, but observationally. Stars are a limited resource. Stars feel eternal from a human perspective, but on cosmic timescales, they are temporary. Every star burns fuel. Once that fuel is gone, the star changes or dies. Right now, the universe is in what could be called its most productive era. Stars are forming, galaxies are active, heavy elements are being recycled. But this will not last. The gas needed to form new stars is slowly being used up or locked away in stellar remnants. Over billions of years, star formation will slow down and eventually stop. No new stars will form. The universe will still contain stars, but they will be old ones, slowly burning out one by one. The long fade into darkness. As time moves forward, the brightest stars disappear first. Massive stars live fast and die young. They explode, collapse, or burn out relatively quickly. What remains are smaller, dimmer stars. Red dwarfs that burn fuel slowly and quietly for trillions of years. Eventually, even they will fade. After that, the universe will be filled mostly with stellar remnants. White dwarfs, neutron stars, black holes. Objects that no longer produce light, only gravity. Galaxies will still exist, but they will be dark collections of dead stars drifting through an ever-expanding void. Black holes and the last sources of energy. For a long time, black holes will dominate the universe. They will merge, grow, and quietly shape their surroundings. But even black holes are not eternal. According to our best theories, black holes slowly lose energy through a process called Hawking radiation. It happens so slowly that we cannot observe it directly today. But given enough time, even the largest black holes will evaporate. When the last black hole disappears, something profound happens. There are no more concentrated energy sources left in the universe. The heat, death of the universe. At that point, the universe approaches what physicists call heat death. Not heat in the sense of fire or warmth, but thermal equilibrium. Energy is spread evenly. Nothing flows, nothing changes. No stars ignite, no structures form. No processes remain that can do meaningful work. The universe does not end with a bang. It ends with silence. A universe still full of particles, but empty of events. Time without change. Here is where things become truly unsettling. Time, as we experience it, is tied to change. to motion, to cause and effect. In a universe where nothing happens, time becomes almost meaningless. Physics still exists, particles still exist, but there are no clocks ticking in any meaningful way. The universe continues, but without a story. Could this end be avoided? Some theories suggest alternatives. Maybe dark energy changes over time. Maybe new physics emerges at extreme scales. Maybe the universe transitions into something we do not yet understand. Right now, these ideas are speculative. What matters is this: according to everything we currently know, the universe is not designed to last forever in an active state. Complexity is temporary. Structure is temporary. Light itself is temporary. Why this matters now? This is not a reason for despair. In fact, it highlights something remarkable. We exist during a brief window when the universe is alive with structure, when stars shine, when galaxies glow, when questions can be asked. The universe had to evolve for billions of years to reach this state, and it will slowly move beyond it. We are not at the beginning, and we are not near the end. We are somewhere in the middle, and that makes this moment rare. The universe is not dying, it is aging. And like all things that age, it carries the memory of what it once was and the inevitability of what it will become. Thanks for watching Daily Dose of Space.